to the second video about finding an inverse. Today we're going to find the inverse algebraically. If you remember from the graphing video, to find the graph of the inverse, all we did was take the x and y coordinates and switch them. So we're going to do the exact same thing, but in the equation. So I'm going to write that down. We're going to swap x and y. And we typically like to have the equation solved for y. So the second step I'm going to say is to then solve for y. Let's try an example. So our first example, remember that f of x really is standing for y. So let's take our first step. To find the inverse relation, we're going to swap x and y. So now I'm going to write that the inverse would be x equals 2y squared plus 3. Now technically, we're done. This is the inverse. However, we like to have equations say y equals instead of x equals. So now I'm going to solve for y. First, I'll subtract 3 on both sides. So x minus 3, I can't really do that, so I'll write x minus 3. And that will get us 2y squared. The next step I would take to isolate y would be divide by 2. Again, x minus 3 divided by 2, I can't really do that, so I'll just leave it as a fraction. And that will equal y squared. The last step to get y by itself would be to square root both sides. However, don't forget that when you square root, you actually have to write down two answers. You have to write down the positive version and the negative version. Again, I can't take the square root, so I'm just going to leave the square root and the fraction as part of my answer. So the inverse of 2x squared plus 3 is plus minus the square root of x minus 3 over 2. Just so you know, the original function, which was quadratic, was shaped like a parabola. If you remember from our graphing video, the graph's inverse will be the reflection over the line y equals x, which should get us a sideways parabola. And that's exactly what this equation does. The positive square root looks something like this, and the negative square root looks something like this. So everything looks good. Let's try the second example. This time we started with the square root. Let's see what happens. First step, I'm going to change that to say y equals. Alright, here we go. Let's swap x and y. So to find that inverse, I would get x equals the square root of y minus 1 plus 6. There's our inverse, but now let's solve for y. So we're going to undo everything that's happening to the y. First thing, I'll subtract 6 on both sides. So I get x minus 6 equals the square root of y minus 1. Next, we're going to have to take care of that square root. What's the inverse of square rooting something? How do you undo it? Well, I would undo square rooting by squaring. Just like that. Now here's my tip. Notice that on this side of the equation, it says x minus 6 squared. Remember that if you're actually going to square it, that you actually have to do x minus 6 times x minus 6. I tend to use a box to do that multiplication, but I'm going to let you in a little tip here. Just leave it alone. Just leave it as x minus 6 in parentheses squared. It's fine. You don't have to actually do out the multiplication. And then on this side, we'll get y minus 1. See? And now we're almost done. We almost have y by itself. We're going to add 1 to both sides. Careful here. Very common mistake. You cannot add 1 to this minus 6. Notice that it's being squared. So before you added the 1, you would have had to have squared it. We chose not to do that, so we're just going to tack it on to the end like this. So I have x minus 6 in parentheses squared plus 1 equals y. Okay, let's think about this. We started with a square root function, which looks something like this. How did we end up with a parabola? That's weird. They're not the same shape. That means we're forgetting something. So I have to actually add something on to my answer. It's a little strange, but I'm actually going to erase my graphs here for a second, and I'm going to show you exactly what's going on. So I'm going to do a quick sketch of these graphs. So let's sketch f of x. Let's see, it was moved right 1 and up 6. So it looks like that. And then here's the line y equals x. And if we reflect the graph over line y equals x, we would get the point 6, 1. Let me do it in a different color. And it would look something like that. Notice that now looks like a reflection. So we didn't get a parabola. Think about the shape that we actually did get. To me, that looks like half of a parabola. Which half of it is it? Well, you might want to say it's the right half. Instead of saying that, I'm going to say its domain. I'm going to put it in the answer. The domain of that half parabola is from 6 to infinity. And that has to be part of my answer. Even though nowhere in the question would it ever say, what is the domain? You have to put it if you only wanted half of the parabola. So don't forget that. You start with a square root graph and you find an inverse. You only want half of the parabola, right? This was only the right side of the parabola. Let's try one more example. All right, start this off, change that to a y. All right, let's make our swap. X equals y minus 3 over 5. Now don't get confused, we're going to solve for y, but don't forget, we have to undo what's happening to the y to undo the division. I know you think that looks like a fraction. Don't forget that fractions are really division problems. We're going to have to undo this division with multiplication. That's going to be my first step. I'm going to multiply both sides by 5. See that? Multiplying by 5 undoes dividing by 5. Now on this side I get 5x equals, on the right side I have y minus 3. And now it should be pretty easy to see that I'm going to add 3 to both sides. So I get 5x plus 3 equals y. Now I didn't say it in the other examples. I saved it actually for the last one. Remember that we learned a new symbol for the inverse. So notice that this function started out as f of x. Its inverse we would call f inverse. There's that little, it looks like an exponent of -1. This is saying f inverse of x would be 5x plus 3. What was the shape of the original graph? Well, it's linear. That means that the shape of the inverse must be linear. I know that lines are functions, which is why I used this function notation. If the other previous examples were functions, I should have also used it there. Go back to that first example. I think that was a sideways parabola. See, that's not a function, so there wouldn't be an appropriate place to use function notation. But the second example, which was half of a parabola, that does pass the vertical line test. So if you wanted to use this new symbol, you could do so. All right, time for your practice in the back.